This last problem has to do with how you can actually apply these geometric series, and it has to do with the future value of annuities, and where this formula stands for, S stands for the future value, R stands for the payment at the end of each period, N stands for the number of periods you're actually going to look at, and I, as always, is our interest rate. Remember, whenever we use interest rates, we always turn them into decimals. So what that means is if your interest rate is, let's say, 6%, you actually turn it into 0.06 by dividing by 100, or moving the decimal place 2 places to the left. So, again, this is a formula that we would need to know that is not given to you. Let's see an example, though. To save for retirement, John put $3,000 into an annuity at the end of each year. He did this for 20 years at an annual interest rate of 2.5%. What was the amount of the annuity at the end of those 20 years? Well, what the formula says is you're going to start with whatever your payment is. What are you putting into the payment first? That's your R, into your annuity each year. Well, each year we're putting in $3,000 into our annuity. Then the formula has inside of these big brackets 1 plus I, where I is your interest rate. Well, our interest rate is 2.5%, which as a decimal means to move the decimal place 2 places to the left, which actually becomes 0.025. So our interest rate is 0.025. And all that 1 plus does is make sure that we're actually attaching the interest rate on top of the original amount. And how many years comes next is it's raised to the nth power. It's going to be in that annuity and building on it for 20 years, so raised to the 20th, and then you have that -1 that never changes. Now, how do you do this? You just have to be careful that you follow your order of operations. Your order of operations, no matter what, is going to tell you to do what's inside your parentheses first, which is that 1 plus 0.025, which gives you 1.025. Then you have to do your exponents, which means raise it to the 20th. Then you can subtract it by 1. And for that top number, what that does is it gives you a pretty bizarre number. When you're all said and done, it gets you 0.6386, and it does continue. The denominator is still just that 0.025. That hasn't been touched. So the next thing, order of operations, says I need to deal with those brackets because they work just like parentheses. So I need to do this division that's inside of those brackets next. So the 0.6386, whatever I got there, divided by the 0.025 on the bottom. Now I would leave that into your calculator and take whatever you get from there and just go ahead and immediately multiply it by the 3,000 that was out in front. And what do I end up in my annuity at the end of those 20 years? I'll end up with $76,633.97. And again, be careful. Try not to round until the very end because it can throw off your answers by quite a bit, especially if you're talking about inputting answers into MyMathLab.